So in this video, let's talk about average precision. You're already familiar with these numbers, so I'm not going to repeat what they mean, but I'm going to remove these two numbers because they are not used in our calculation of precision and recall, so that we have less clutter on the page. Now at this point, you know how to calculate the precision. It's nothing but 4 by 6 and recall is nothing but 4 by 5. So if you want to help visualize these precision and recall values better, we can actually plot them as a precision on y-axis and recall on x-axis, so that you get a visual representation of that very point which corresponds to this value of precision and that value of recall. So let's see how that looks. So here we have precision on y-axis and recall on x-axis, and if that is 1, that point there, then precision is going to be, in this case, 4 by 6, which is somewhere there, it is 0.666, and recall is going to be 4 by 5, which is 0.8. So it's going to be somewhere there if that is 1. So our point corresponding to this situation is going to be there. And this corresponds to the values of precision and recall that we just calculated. Now if we change our confidence threshold, then the precision and recall both are going to change. Specifically, if we increase the confidence, then our precision is going to go up and recall is going to go down. So let's try to do that. We have increased the confidence here and our recall is going to go down. So now it is 3 by 5 and precision has gone up. Now it is 3 by 4. So if you plot these two values on our precision recall plane, let's see how that looks. So here the precision is 0.75, 3 by 4, that is 0.75, which is somewhere here, and recall is 3 by 5, which is 0.6, which is somewhere there. So the point corresponding is there, and the previous point was obviously here, which corresponded to our default confidence. Now we have increased the confidence, the point has gone up here. Let's try to reduce the confidence and see how that looks. Now if you reduce the confidence, the recall is going to go up and precision is going to go down. So in this case, recall has become 5 by 5. It's gone all the way up, and precision has gone down. It's become 5 by 9. So if you plot this, let's see how that looks. So here we have precision as 5 by 9, which is somewhere between 0.5 and 0.6, which is here, and recall is obviously 1, which is here. So our point is here. So now you see a pattern that if confidence is lower, this point tends to go down, and if confidence is higher, this point tends to go up. So let's focus on this graph for a while. Now if you want more points on this graph, you would want to calculate the precision and recall with various different values of confidence, so that you get more points here corresponding to each confidence level. And you can imagine that as I increase confidence, you're going to get points which are higher up, and let's see how that looks. That's exactly how it looks. This is the highest confidence level, and as you keep lowering the confidence, you get all of these points, and this is the least confidence level, for which you have least precision value and highest recall value. And here you have highest precision value and lowest recall value, right? Because this corresponds to very low recall value, and this corresponds to very high recall value but the lowest precision value. Now if you want to calculate the average precision, you basically have to sum all the precision values corresponding to these points. So this one's precision is somewhere there, this one is somewhere there, this one is somewhere there. So you have to sum all of them up and divide by 7. It's as simple as that. So let's try to do that. Here I've just helped you visualize that precision value for each point better. So here the vertical height is the precision. So these are all the precision values. So basically you have to sum all of them up and divide by the number of points. In this case it is 7. So you just have to divide the sum of this by 7. But there's a flaw in that, because if you do that, you are kind of ignoring the fact that that particular precision value that we are talking about has sustained for a specific duration of recall. So for instance, this precision value has sustained for this duration of recall. This precision value has sustained for this duration of recall. This precision value is sustained for this duration of recall. And as you see that the duration of recall for which each of these precision values is sustained is different, right? Here it is low, here it is quite high, here it is quite low again, and it's different for all these cases. So if we just find the average of the precision values by summing them up and dividing by 7, then we are not doing justice to the duration for which those precision values were valid in this situation. So to help do that better, we're going to take a weighted average. And if you've heard of that term, it's basically the amount of duration for which a specific value is sustained. So in this case, for instance, this precision value is sustained for this duration. So the weight of this is going to be this multiplied by this. Here it's going to be this multiplied by this. Here is going to be this multiplied by this, because that is the amount of time for which it is sustained. Actually, it's not time, it's the amount of recall points for which this precision has sustained. So if you do that, it's almost like trying to multiply this height with this width, which looks like, if you draw a rectangle here, then it's the area of that rectangle. So to help you visualize better, I have drawn these widths everywhere. So that width is nothing but very similar to this width. It's exactly same as that width. That width is exactly same as that width, because these are all vertical rectangles. So when we multiply this with this, we are actually finding the area of that rectangle. And now we can actually just sum all of that up, because now we have actually weighted all of these precision values by multiplying them with the amount of recall values for which they have sustained. And by doing that, we are actually finding the areas of these individual rectangles, and by summing all of these weighted precision values, we are actually getting the average precision, and that is the same as the sum of all these areas of these rectangles, which is nothing but the area under the precision recall curve.